we're going to be writing the equations of lines that are parallel and lines that are perpendicular. You don't have these first couple slides on your note cards or notes, so just follow along. For this first one, it says find the slope of each of these lines. How can I find the slope of the line that's on the graph there? What? Pick 2 points? What would you suggest? 0, 2, like this one right here? Good ones that make nice intersections, right? Like it would be bad to pick that point because I'm not sure where it is on the y-axis. Yeah. Okay, so if I use those 2 points, how am I going to find the slope then? Count it, right? Go up and over. So I go up 1, 2, and then I went right 1, 2, 3, 4. So my slope up 2 is positive, right 4 is positive, but our slopes always need to be in simplest form. So how would you say that then? 1/2, good. Because it's hard to read some of the colors on there. Sorry. Okay, second line. 0, -2, and 4, 0. So I can count the slope again. Up, 1, 2, right, 1, 2, 3, 4. Wow, the slopes are what? No, the slopes are the same, but the lines are parallel. So what can you conclude about the slopes of parallel lines? They have the same slope. You might want to write that on the top. It's written there. I mean, it's like all typed out in a bunch of words, but it might be easier just to write slopes of parallel lines are equal. Or you can just underline or highlight what's in the text, yeah. Slopes of parallel lines are equal, the same. They have to be the same, which makes sense because parallel lines can't intersect. So if one line moves up 2 and right 4, then the other one better move up 2 and right 4 so that they stay the same distance apart. All right, this guy, I'll name these lines. We'll say he's J and this line is K. What do you know about these 2 lines? Yeah, since they make a right angle, they gotta be perpendicular. Let's find the slope of each of these. How would you suggest I do that? Pick 2 points and count the distance between them. This one was supposed to intersect here, and this one's right there. So if I find the slope of line K, starting down here, I go up 1, 2, and right 1, 2, 3. So up 2, right 3, those are both positive movements, so I have to keep the numbers positive. Can't reduce that, so we'll go to the next line, J. This is supposed to be here, and then down to here. So I go down 1, 2, 3, 4, right? And over 1, 2, 3. That's not right. Oh, this one's not a point. Sorry. There you go. Is that better? Okay, let's go there. I go down 1, 2, 3, and then I go right 1, 2. So down 3, right 2. What do you notice about the slopes of perpendicular lines? They're opposites. One's positive, one's negative. And yeah, they're flipped around. They're called reciprocals. They're opposite reciprocals. Opposite meaning positive, negative. Reciprocals, they get flipped. You can underline that or highlight it in the text, or you can just write it. Slopes of perpendicular lines are opposite reciprocals. Opposite, one's positive, one's negative. Reciprocal, that's when you flip the fraction. You have to have both. You can't just be opposites, and you can't just be reciprocals. So you have to be both. All right, practicing this then. Rows. If I have a line that has a slope of 2/3, what would be the slope of the line parallel to that guy? Yep. Rows, how about the one that's perpendicular to that line? Good, -3/2. Jack, if the line has a slope of -3/4, what would be the parallel slope? Good. Jack, how about the perpendicular slope? Yeah, positive 4/3. Wiggly. The slope of the line is -6. How about one that's parallel to it? Good. How about one that's perpendicular to it? Awesome. Positive 1/6. Emma, line parallel to this first one. Yep. How about one that's perpendicular to it? Good. -5 or -5/1. I'm not going to do this one because you don't know why I typed it that way. Slopes should always be as improper fractions. Rashid, I got a slope of 0. One that's parallel to it. 0. How about one that's perpendicular to it? Well, let's think about it. What kind of lines, Rashid, have 0 slopes? Good. Rashid, what kind of lines are perpendicular to horizontal lines? Vertical lines. Rashid, what's the slope of a vertical line? Remember that link? There isn't a slope. This link is the no slope because you can make an N with a vertical line. But having no slope is the same as saying it's undefined. That says undefined. Good. So here my given line has no slope. So Sid, a line that's parallel has no slope. How about a line that's perpendicular? Good, 0. This is a vertical line. A line perpendicular to it has to be horizontal, so the slope's going to be 0. Okay, let's put this into play now. Number 1, are the lines x plus 5y equals 4 and x equals 5y plus 4 parallel? I have a typo. Yours is x equals -5y, yes? Plus 4? Okay, I'll put that in here. How are we going to figure out if these lines are parallel or not? Set them equal to y?
You could just add 5y for the second one over to the left,
Yeah.
and then they equal.
But how do you know they're parallel then?
Because slopes of parallel lines are equal.
So what would be the slope of the lines?
A number.
What? You're going to change your mind?
Yeah.
I want to set them equal to y, because that would be what form of a line? Slope-intercept. Good. You need to put your equations in slope-intercept form, because then whatever is attached to the x is your slope. So you have to solve these for y. My first line, x plus 5y equals 4. What kind of form is that, guy? Standard form. Good. It's x and y are on the left. They're both or x is positive, and there's no decimals or fractions. I need to solve this for y. So subtract x over. 5y equals -x plus 4. Kilgore, this is your one and only warning. Got it? Okay, thanks. Divide everything by 5. Y equals, what number, what coefficient is in front of my x? A 1. So when you divide that, you get -1/5 x plus 4/5. What is the slope of this line? -1/5. Good. Now I have to find the slope of my other line. X equals -5y plus 4. Is this standard form? No, because I don't have x and y both on the left side. How are we going to solve this for y? Subtract 4 to the left side. Are you okay with me rewriting this then as -5y equals x minus 4? Okay. Then what do I have to do? Divide by -5. Y equals, what's that coefficient out front? a 1. So this becomes negative 1/5 x. A negative divided by a negative is positive 4/5. What's the slope of this line? Negative 1/5. So would you say that they are parallel? Hey, it's the same line. How do you know that? It's because the y-intercepts are the same. So if it's the same line, are they parallel? No, wouldn't they intersect along every single point along that line? Oh yeah, so actually these are not parallel. Because it's the same line, so they can't be parallel. Just because they have the same slope, then you gotta check your slope-intercept, or your y-intercept. Cool. Number 2. Line 1 contains points P and Q, and line 2 contains R and S. Are lines 1 and 2 parallel? Maybe. How can we figure it out? Yeah, use your slope formula to find the slopes between the points. You want to find the slope between the points because remember, parallel lines have the same slope. Cade, what else did you say? You could make a graph. And then couldn't you count the slope between the 2 points like we did at the beginning? Yeah, show me that. If you would rather make a graph and count, show me you're doing that. Otherwise, you can use your slope formula. Blah, blah, blah. M equals, what'd you say, Franson? Y1 minus Y2 over X1 minus X2. You have to compare slopes if you want to know if the lines are parallel or not. Line 1. I have points P and Q. P comes first, so I'm just going to call that my X1, Y1. The little 1 tells you it comes from the first point. X2, Y2, that just tells you it's coming from the second point. The slope of line 1 equals Y1, 3, minus Y2, 5, all over X1, 0, minus X2, negative 2. Simplify, what's 3 minus 5? Negative 2. How about 0 minus negative 2? Becomes positive 2. Watch that. Those of you that handed in the slope worksheet and even Fridays, you're making simple mistakes there. What's the slope of line 1 then? Negative 1. Good. Your slopes always need to be written in reduced form. Then I have to do the same thing for line 2, which has R and S. So I'm going to relabel this X1, Y1 for point R, and X2, Y2 for point S. And then I'm going to find the slope of line 2. Y1, negative 7, minus Y2, negative 10, all over X1, 0, minus X2, 3. Negative 7 minus negative 10 becomes plus. So negative 7 plus 10. Negative 3 or positive 3? Positive, right? It'd be like saying 10 minus 7. How about 0 minus negative 3? Negative 3. So what's the slope of line 2? Negative 1. So are the lines parallel? Why? Good. You would say, yes, parallel, same slope. It says to explain, so explain. Can't remember that slope formula? Then graph it and count it. You guys can count, right? Hopefully. Questions on 2. Alrighty, number 3. Write an equation, bless you, using point slope form for the line parallel to 6x minus 3y equals 9 and contains the point negative 5, negative 8. Write the final equation in slope-intercept form. Okay, so we're going to write the equation of a line that's parallel to this line, 6x minus 3y equals 9, and goes through the point -5, -8. Anytime you're going to write the equation of a line, what two things do you need? A point and slope. It says use point slope form. If you're going to use point slope form, what two things do you need? Point and a slope, right? Okay. They're telling us it contains or goes through -5, -8. We already know the point we want, but we still have to find the slope. It's going to be parallel to this given line, 6x minus 3y equals 9. Well, what do we know about parallel lines and their slopes? They're the same. So what do I have to figure out about this given line? What do I have to find about it? It's slope, right? How am I going to find the slope of this line? Good. Put it into y equals mx plus b form. Right now it's in standard form. It doesn't tell me much. But if we can rewrite it so that it's in slope-intercept form, I'm going to get my slope. That means I solve it for y, so I have to bring my x over. How do I bring my x's over? Subtract them. Careful here. Common mistake that I saw. This is -3y. You have to bring that negative down with you. You can't just call it 3y. Minus 6x plus 9. Then what do I have to divide by? -3. Y equals, what's -6 divided by -3? +2. 9 divided by -3? All right. So these are the same lines. 6x minus 3y equals 9, and y equals 2x minus 3, just two different forms of it. What's the slope of my line? 2, right? It's whatever's attached to my x. Okay, so I'm going to write the equation of a line that's parallel to this one and goes through -5, -8. If they're parallel, what slope should I use? 2. All right, so now using point slope form, y minus y1 equals m times the quantity x minus x1, we're going to write our equation. Which value should I substitute for y1? -8. Good. How about for my m? 2. Bless you. How about for my x1? -5. Good. Another common mistake. It's y minus -8. So what does that become? +8 equals 2 times the quantity x minus -5, x plus 5. This would be point slope form where I have it stopped right now. This one is not, because you need to simplify the minus minus. This is point slope form. Don't distribute if it were to say stop at point slope form. But it actually tells us to keep going to slope-intercept form, so I need to distribute and solve for y. Pull that through. Y plus 8 equals 2x plus 10. Then what do I have to do? Subtract 8. Y equals 2x plus 2. This line, 2x plus 2, is parallel to this one, so they have the same slope, and they cross through different points on the y-axis. One's at -3, one's at +2. So same stuff we were doing last Friday and Thursday, but now we're just adding if it's going to be parallel or perpendicular. Okay, number 4. Line 1 contains points M and N, and line 2 contains points P and Q. They want us to decide if these lines are perpendicular. Well, what do I have to figure out about the lines? They're what? Slopes. Find the slopes of the two lines. You can do it two ways. You can graph it, or you can use the slope formula like we did on number 2. Try it here on your own. Did you get -7/2 for line 1 and -2/7 for line 2? Mm-hmm.
Oh, shoot.
Would they be perpendicular? What do you mean? They're reciprocals, though. But they're not opposite. Good. They're both negative. You have to have a positive and a negative, and then also be reciprocals. So we'll say not perpendicular, not opposite. Slopes, not opposites. You have two negatives. You need both, a positive and a negative. What? You sure? Did you get these two slopes? Okay, they're not perpendicular though because they're both negative. You need one to be positive and one negative, plus being reciprocals. Okay, all right. Number 5. Write an equation using point slope form for a line perpendicular to 5x plus 2y equals 1 and contains the point 10, 0. And then write your final equation in slope-intercept form. Write the equation of a line using point slope form. What two things do we need then? Point and the slope. They tell you what you need. Here's your point, 10, 0. Contains, goes through that point. But I'm missing my slope. The slope I want to use is -5/2. Where'd you get that? I got to solve that equation for y. So I can find the slope of that line. Okay, so I need to take this one that's in standard form and solve it for y so that I know the slope of the given line. Subtract 5x. 2y equals -5x plus 1. Divide by 2, and you get y equals -5/2 x plus 1/2. So what is the slope of my given line? -5/2. Is that the slope I want to use then? What kind of lines are we doing? We're doing perpendicular lines. What do we know about the slopes of perpendicular lines? They're opposite reciprocals. So the perpendicular slope, Kilgore, should be what then? Good, a positive 2/5. The given line is -5/2, but since we're doing perpendicular, it's got to be the opposite reciprocal, so positive 2/5. So we are going to use the point 10, 0, and then the slope of 2/5 to write our equation. Using point slope form, that's the y minus y1 equals m times the quantity x minus x1. What should I substitute in for y1? How about in for my slope? How about in for x1? 10. Good. There's point slope form without distributing. To get it into slope-intercept form, I get to distribute. On the left side, y minus 0 just becomes y. Distribute in, 2/5 times x is 2/5 x. 2 times 10, 20, divided by 5, 4. So this would be -4. This line in black is perpendicular to the given line in blue. They have opposite reciprocal slopes. When they intersect, they'll make a 90-degree angle. Read carefully. Okay, once you have that copied down, flip it over and do number 6, both parts. Decide whether the given lines are parallel or not. All right, for 6 part A, y equals -1/2 x plus 5. Do I have to do anything to this to find the slope? No, what is the slope? Good, -1/2. It's in slope-intercept. The second one, 2x plus 4y equals 9. Do I need to do stuff to that one? Yeah, I got to get it into slope-intercept form. Right now it's in standard form. Subtract 2x over. 4y equals -2x plus 9. Divide by 4. Y equals -1/2 x plus 9/4. What's the slope of the second line? -1/2. Are the lines parallel? Yeah, because the slopes are what? Yeah. So right, yes, parallel, same slopes. Yeah, I don't know. One something? Hang on, I'll be right there. Part B, I don't have to do anything to the first one. The slope is negative 1/2. Subtract 2x over on the second line. 4y equals negative 2x plus 20. Divide then by 4 to get y by itself. Y equals negative 1/2 x plus 5. Negative 1/2, negative 1/2. Are they parallel? But they have the same slope. Good, it's the same line. So you should say no, it's the same line. They're going to intersect. Like 174, I think. Check that page. Nope. Because he's leaving and worry about yourself.
Worry about yourself.
All right. Here we go. Number 10. Write the equation using point-slope form of a line of the perpendicular bisector of the segment joining negative 3, 7, and 5, 1. Okay, segment stops, right? So here's this segment. These points aren't going to be exact, but I'm just going to throw them on here quick. There's my segment. I want to write the equation of a line that's the perpendicular bisector of the blue one. Two things there, perpendicular, bisector. What's it mean if the lines are perpendicular? They make 90 degrees. There's the perpendicular part of it. What about the bisector? Right in the middle, it cuts it in half, right? So like this portion would be the same as this portion. So if the black line is the perpendicular bisector, where does it intersect the blue one at? In the middle. What do you call that point? Midpoint. Good. So it's intersecting the blue line at its midpoint. We're trying to write the equation of a line. What two things do you need to write the equation of a line? Point and the slope, right? Because it says use point-slope form. That's the point we're going to use, the midpoint, but I have to figure out what it is. Anyone remember how to find the midpoint between 2 points? What's it mean to be a midpoint? Be right where? Right in the middle. Divided by 2. Sum divided by 2. You have to find the average of the two endpoints. So you add the endpoints and then divide by 2. So if these are my endpoints, we'll say negative 3, 7 is the first one, x1, y1. And then 5, 1 is the second one, so x2, y2. So that would be negative 3 plus 5 over 2, comma, 7 plus 1 over 2. Then simplify. What's negative 3 plus 5? 2. And 2 over 2 is 1. What's 7 plus 1? Divided by 2. 4. There's your point. That's the midpoint of the blue segment. That's the point that the black perpendicular bisector goes through. But I have to figure out what slope I want to use. What do you think? Well, what kind of lines are they? Not just the reciprocal, the opposite, because they're perpendicular. But I have to find the slope of the blue line first before I can find its opposite reciprocal. Can I find the slope of the blue line? Yeah, can I do y1 minus y2 over x1 minus x2? Sure. Ready? M equals 7 minus 1 all over negative 3 minus 8. What's 7 minus 1? What's negative 3 minus 8? Or excuse me, minus 5? Reduce it. All right, I'll get your homework. Yeah, right. You can get it offline. It's offline. What's your point?